So today, the speaker is going to be Bruce Schneier. He's a CTO, IBM Resilient, and Special Advisor to IBM Security from IBM Resilient.
Okay, so that was a lot of announcements. We will have them straight. I'm pretty sure the IBM home is not actually a home. Sorry, the Google home is not an actual home provided by Google, but a device you put in the home you already own. So just to be clear on that. So thanks for coming. It's always nice to see everybody at RSA yet again. So in 2011, Mark Andreessen said that software is eating the world. It's an interesting quote, and I think what he's saying is that software is permeating every aspect of our lives. And the way I think of it is that everything is becoming a computer. And so your microwave oven is a computer that makes things hot. Your refrigerator is a computer that keeps things cold. Your smartphone is a small portable computer that makes phone calls. An ATM machine is a computer with money inside. Your car is not a computer, it's probably a 100+ computer distributed system with 4 wheels and an engine. And this is happening at all aspects of our lives. Right? I mean, a nuclear power plant is a computer that produces energy. And as everything becomes a computer, computer security becomes everything security. And this has 2 important ramifications for us. One, the knowledge that we all have about computer security will soon be more broadly applicable. It'll be applicable to everything. And 2, the restrictions and regulations that are in the physical world are coming into our computer world. And the beachhead of all of this is the Internet of Things. So when I think of the Internet of Things, I think of it in 3 pieces. There are the sensors that collect data about us and our environment. Right? So smartphone location data, or smart thermostats and light bulbs knowing who's in the room, or internet-enabled street and highway sensors. There's the smarts that figure out what all this data means and what to do about it. Right? So it's processing, it's memory, and a lot of it's in the cloud. And the third part are the actuators that affect our environment. And so the whole point of that smart thermostat is to regulate the temperature in the room. The whole point of sensors in our cars is eventually going to be to drive autonomously. So when you think about it, we're creating an internet that senses, thinks, and acts. And this is the classic definition of a robot. So I argue that we are together creating a world-sized robot, and we don't even realize it. Now, this isn't a robot in the classical sense. We tend to think of robots like we see them on television and in the movies. So discrete, autonomous entities in a metal shell with the smarts inside and the sensors and actuators on the surface. Data from Star Trek. But that's not what we're building. What we're building is distributed. It doesn't have a central brain. Different parts are controlled by different people. It doesn't have a singular goal or focus. And most importantly, it's not something deliberately designed. This is an emergent property of the computers and networks that we've built. But for our purposes, it is smart things that act on the world in a direct and physical manner. Right? And of course, smart's relative. It's actually pretty dumb. But it's getting smarter. And it's getting more powerful through all the interconnections we're building. And this is what's eating the world. This is what means Internet security becomes everything security. It means all of the lessons we know about our world become broadly applicable. lessons of security and complexity, of vulnerabilities and patching, incident response, attackers, their tactics. Right? Everything we've done for decades is going to be everywhere, with two real important differences. One important difference. The effects are greater. And so decision-making algorithms are going to have lasting and serious effects. We think of predictive policing, algorithms that process loans or college applications or government services, algorithms that determine who gets released from jail or what kind of treatment you get at the hospital. Right, we're seeing these systems vertically integrated in a way that threatens the openness and accessibility of the internet. Right, more centralization, more monopolies. The proliferation of sensors that erodes privacy and allows ubiquitous surveillance on a global scale. Remember that Google Home you might win? You know, when all of these have the potential to deepen social inequities and reinforce social divides. And specific to our field, the immediate security threats are greater. Right? Cyber-physical systems have real-world effects. And the integrity and availability threats are much worse than the confidentiality threats. Right? So we're worried about information manipulation as an increasing threat. And both former DNI James Clapper and current NSA Director Mike Rogers have both testified about this. Denial of service is increasingly a threat as these systems become more essential. I mean, it's one thing for Reddit to be DDoSed. It's another for your home thermostat to be DDoSed in the winter. I mean, hacking is increasingly a threat in SCADA systems. And then as these things affect our life and property, there's a threat there. And of course, confidentiality is still a threat, especially as these systems become more independent and autonomous. I mean, so we spend a lot of time ensuring that our communications, our encryption, can't be broken. Who here wants intelligent, independent, autonomous robots to communicate securely in a way that we can't listen? Right? I'm not convinced that's a good idea. Right? We're in a world where our smartphone is emerging as the centralized control device, which leads to single points of failure. We know about class breaks are even more serious now. But the whole full disclosure debate takes a very different tone when we're talking about a vulnerability in aircraft avionics. And so same computers, different outcomes. Or put another way, there's a fundamental difference between crashing your computer and you lose your data and crashing your pacemaker and you lose your life. It might be the same operating system and the same vulnerability, but the effects are night and day. So there are 5 truisms from internet security that we need to take to the broader world. So 1, most software is poorly written and insecure. Right? We know this. We in the computer world don't want to pay for quality software. Right? Good, fast, cheap, pick 2. We picked fast and cheap. And we do it again and again. And we had good reasons, but we might want to rethink that. Because we know that poor software is full of bugs. And we know that some bugs are security vulnerabilities, and some of those are exploitable. But truism 2. The extensibility of computerized systems means that everything can be used against us. Extensibility is fundamental in computers and doesn't exist anywhere else. Because computers can be programmed to do anything. The computer in your toaster can get additional features, can be reprogrammed, can get malware in a way that manual systems can't. So these continuously evolving systems are hard to secure because we can't anticipate every use or every condition. And these systems can be upgraded with additional features, both ones you like and ones you don't know about. Real different. This doesn't happen to cars pre-computer. It can't. Truism 3. The complexities of computerized systems result in new insecurities. Now, we know this deep in our core, that complexity is the worst enemy of security. We know it for all sorts of reasons. We talk about attack surfaces and attackers having first mover advantage. We talk about agility of attackers and the ponderousness of defenders. But we talk about all this stuff, but it basically means two things. That attack is easier than defense. It's kind of neat when former President Obama said that a few months ago. It felt like he was listening to my talks. And two, that security testing is hard in a way it wasn't hard before computers. Too many options, too many configurations, too many interactions. You can't just do an underwriter's laboratory test for computer security like you can do for light bulb safety. It just doesn't work. Truism 4. There are new vulnerabilities in the interconnections. Right? The more we connect things to each other, the more that vulnerabilities in one thing affect other things. Right? So the Dyn attack is a great example of that. Vulnerabilities in DVRs and CCTV cameras allow a hacker to knock over a DNS server, which allows them to drop a couple dozen popular websites. But we see it again and again. There's a great story by Matt Honig of how his identity was stolen. And what happened is, I think I'm going to get this right, there's a vulnerability in his Amazon account, allowed hackers to get into his Apple account, which allowed them to get into his Gmail account, which allowed them to drop his Twitter account. And it was a cascade of failures. Really good article to read. Or Target Corporation, where a vulnerability in their HVAC supplier gave hackers an avenue into their corporate network. And this is really hard to fix, because no one system might actually be at fault. Security is not composable. You can have two secure systems, put them together, and you get residual insecurity. And not true in the real world in the same way. My fifth trend, last, is that computers and networks are vulnerable in different ways. And this is important. The failure modes are different between computer systems and the mechanical systems they replace. For a whole bunch of reasons. A lot of it is that the internet is naturally empowering. It allows things to scale, including attacks. So the notion of a class break, where you could have secure everything, you wake up one morning, and every single copy of, PDF is insecure. It doesn't happen in the real world. So we know that driverless cars will be much more secure and safe than regular cars until they're not. Right? And that will not surprise us, because we know how class breaks work. That will surprise the rest of the world. The whole software monoculture makes this work, because we all are subject to the same vulnerabilities. And fewer attackers can do more damage because their ability to scale attacks. And this becomes more dangerous as systems get more critical. Remember, we're building a robot that affects the real world. So we are worried about crashing all the cars, shutting down all the power plants, and so on. Right? It's science fiction still, but not stupid science fiction. And we also know we're not concerned about the security against the average attacker. We're concerned about security against the 5 sigma guy who can ruin it for everyone. Right? One person writes the Mirai botnet, then publishes his code, and within a week, it's in dozens of botnets. That's our world. And soon, that'll be everyone's world. So this is a real hard technical problem, and there are a lot of people working on it. There are a lot of companies on the show floor, and a lot of people still working in stealth. Different ways to secure the IoT or poorly secured systems. And it's whether it's secure IoT building blocks or security systems that assume a malicious environment, ways to limit catastrophic effects. There's a lot of good stuff being researched. I don't think we're going to solve this anytime soon. We're more likely to muddle through with various technologies, basically as we've done for the past couple of decades. I mean, in the near term, there are a lot of people trying to come up with a list of things IoT vendors should be doing. I've been collecting those lists. I posted it on my blog last week. I think I had 19 different IoT security guideline documents. They all basically say the same stuff. Right? Good security practices, good testing, patching, avoiding known vulnerabilities, secure defaults. Some of them talk about data minimization, data protection, data accessibility, supporting responsible research, fail-safe functionality. Some talk about a Faraday mode that should be able to function even without the internet. Interoperability, data portability. I mean, we all could write these documents. And they're all good lists. The question is how to get them adopted. How do you get the company that's making the internet-enabled toy or toaster or toothbrush? There actually is an internet-enabled toothbrush. Right? How do we get them to adopt these? I mean, until now, we've largely left computer security to the market. Right? And this conference is a testament to that market. But if you're a vendor here, you know that the incentives only work OK. Right? There's lots of externalities to worry about. The interdependencies are really great. And there are collective action problems we have here that markets just can't solve. But we have been OK with these imperfect solutions because the effects of the failures just weren't that great. And that's what's changing. Additionally, the economics of the Internet of Things is different. So our computers and phones are as secure as they are for two basic reasons. One, there are teams of engineers at companies like Microsoft and Apple and Google that are doing their best to design the things secure in the first place. And two, those same teams of engineers are able to quickly and effectively deliver security patches to all end-user devices when vulnerabilities are found. And patching has gotten much better in the past couple of decades. So not great, but it's real good. But that whole ecosystem doesn't exist for low-cost embedded systems like DVRs or home routers. And they're built at a much lower profit margin. They're often built offshore by third parties. And there just aren't security teams associated with those devices. I mean, even worse, a lot of them have no way to patch. I mean, the way you update your DVR right now is you throw it away and buy a new one. And that's actually not a good mechanism. I mean, also, we get our security from the fact that our devices keep churning. You replace your phone every couple of years, your computer maybe every 3 years. And that's not true for these cheap embedded systems. I mean, I replace my DVR, every 5 to 10 years? My refrigerator every 25 years? I mean, I expect to replace my thermostat approximately never. And that's not going to work, because our field doesn't work that way. And the market's not going to fix this because neither the buyer nor the seller care. I mean, think of that DVR that was used in the Mirai botnet. The buyer of it has no idea it's part of the botnet. It's working perfectly. It was cheap. What's the problem? The seller doesn't care. It's working perfectly. It's cheap. What's the problem? This is all an externality. And really, sort of even more broadly, the market tends not to fix safety or security problems without government intervention. I mean, think of food safety and security. Think of automobile safety, airplane safety and security, product safety, what we're going through right now with the safety of financial products. Without government intervention, you don't get the levels of security you need. And this is getting big fast. I saw a Gartner number. We can argue with it. But they have us adding 5.5 million devices to the internet every day. That's about 2 billion per year. And most of it's low-hanging fruit for attacks. Right? It's entry points into larger systems, gives us larger and more powerful botnets, and some of it's controlling surprisingly highly critical systems. So in general, we have two paradigms of security. This paradigm A that comes from the world of dangerous things. And this is the paradigm of getting it right the first time. So think of planes, automobiles, medical devices, buildings. This is the world of regulations, of codes, of standards, certifications, testing, licensing. Then this paradigm B from our heretofore benign world of software. And this is the paradigm of make sure your security is agile. I mean, this comes from, I guess this is update and rapid prototyping and survivability, recoverability, mitigation, adaptability. Right? We can't get it right the first time. We can fix it fast. In a sense, we're trying to balance the cost of failure and the cost to fix. Here, the cost of failure is very high. Here, the cost of failure is low, and the cost to fix is low. Here, the cost to fix is high. Like a product recall of an automobile, expensive. And rebuilding a building after it collapses on all of us, very expensive. Right? That doesn't happen here. These two worlds are colliding. In our cars, I guess literally, our medical devices, building control systems, traffic control systems, voting machines. And we need to somehow make these paradigms collide. And we're not doing great. So we live in a world where Windows XP, which is what, 14 years old, is still running 95% of our ATM machines. Right? There are medical systems that cannot download security patches because by doing so, it invalidates the testing required by the medical certification systems to be usable medical devices. Or a nice comparison from last year, actually just 2015, Chrysler recalled 1.4 million cars to fix a software vulnerability. So they actually had a product recall for a software update. September of last year, Tesla had a vulnerability in their Model S cars, downloaded a patch to their users overnight. I mean, it's sort of interesting to watch the two different worlds. Primarily, this is a policy problem. This is a problem of law, economics, psychology, sociology. And getting the policy right is critical. Getting the economics and psychology correct is critical. Think of email security. Think of spam, anti-spam. Right? Policy, when you get policy wrong, you have serious problems. Apple versus FBI, a real good example of that. Or the whole debate about the vulnerability equities process. These are very technical policy debates we're having in our industry. And law and technology have to work together. So I think this is the most important lesson from Edward Snowden. I mean, we always knew that technology could subvert law. What Snowden showed us is that law can subvert technology, and that both have to work together. So I have a practical problem when I think about government involvement, is that there isn't a regulatory structure to tackle this at a systemic level. So there's a fundamental mismatch between the way government works and the way technology works. Right? Government operates in silos. FAA regulates aircraft, FDA regulates medical devices, FTC regulates privacy and unfair and deceptive trade practices in certain contexts. I can go on. But each agency has different approaches and different rules, and few have expertise in these issues. The internet is this freewheeling system of integrated objects and networks. Right? It grows horizontally, it destroys barriers, it allows systems that never communicated to communicate. I mean, already there are apps on my phone that can log health information, control my energy use, and communicate with my car. And I think I've just crossed 4 government regulatory agencies, and like, it's still morning. And so any solutions we come up with have to be holistic, have to approach computers as computers, whether they're cars, drones, or phones. It's just different peripherals on the same computer. So governments have a limited toolbox they use when they look at industries. They can do things ex ante, kind of before the fact. And that's like regulations on products or product categories, licensing of individuals or products, testing requirements. There are things they can do ex post, after the fact. And that's like fines for insecurity or liabilities when things go wrong, torts. There's things they can do sort of in the middle. So think of product labeling and other transparency measures. Think of consumer reports like ratings agency or an NTSB like forensics agency. And this stuff they can do kind of on the side. And that might include funding for education and research or using its own procurement power to drive requirements. I mean, that's basically what governments can do. And we're seeing a bunch of movement, I think primarily in Europe. There's a new General Data Protection Regulation, the GDPR, which has strong requirements for privacy and even stronger penalties. Goods manufactured and sold in Europe have to have a mark, and you see it says CE, which basically means complies with all applicable standards. And there is already an applicable standard for vulnerability disclosure. And they're working on one for secure defaults and for patch management. And this kind of stuff gets incorporated in trade agreements like GATT, and then suddenly you see it in more places in the world. And the international considerations are interesting, because software is write once and sell everywhere. So for automobiles, you'll see car manufacturers make different cars for different environmental regulations. So they're not going to sell the same car in California that they sell in Mexico, because the environmental regulations are different. But for software, it's easier to sell one thing. If you have to make it more secure because the EU demands it, you might as well sell it that way everywhere because you don't lose anything. So my proposal in the US is that I think we need a new regulatory agency. Now, there's a lot of precedent for this. In the past century, many technologies have led to the formation of new government agencies. Right? Trains did, cars did, airplanes did, radio did. The Federal Radio Commission became the FCC. Right? Nuclear power led to the formulation of the Department of Energy. I mean, for a couple of reasons. New technologies need new expertise, and new technologies need new controls. And this is something markets can't solve. Markets are, by definition, short-term and profit motivated. That's what they're supposed to do. They don't solve collective action problems. And we need some counterbalancing force to corporate power. And government is the entity we use to solve problems like this. So of course, there are lots of problems here. I don't think we really have the expertise and willingness to do the work. Regulatory capture is always a problem. We have, here in the United States, general unwillingness of Congress to do anything proactive. And there's a real problem of security versus safety. Right? The difference between a static safety environment and intelligent and adaptive security environment, and how that changes things. And also how to regulate security in a fast-moving technological environment. Not at all clear. Right, so the devil's in the details here, and I don't have them. But I submit that this is the worst possible idea except for all the others. And I'm not sure the alternative is viable any longer. Because usually when we're asked at regulation, we answer we want none of the above. And I don't think that's going to fly anymore. Because I think governments are going to get involved regardless. The risks are too great and the stakes are too high. The government is already involved in physical systems, and the physicality of the Internet of Things will spur them to action. If not that, then it'll be the actual robots. Right? My guess is the courts are the first branch of government that will set precedent here, that there will be torts that will be recognized. I think the existing regulations come in second, and I think Congress and laws play catch-up. But Congress will follow. I mean, nothing motivates the US government like fear. mean, all the strong bias we have towards leaving the market alone tends to disappear when people start dying. When there's a disaster, people demand that government do something. I think of 9/11 and the formulation of Department of Homeland Security, a massive government bureaucracy. And if we don't watch out, what we'll get will be something like Homeland Security, something ill-conceived and ham-handed and doesn't work very well. So our choice here is not government involvement or no government involvement. Our choice is smarter government involvement or stupider government involvement. And we have to start thinking about this now, otherwise this will be imposed on us. We need to make sure that the regulations that are coming don't stifle innovation. Now, we always hear that as a threat when everyone talks about regulation. And it's unclear whether it's true. We heard it with, I don't know, restaurant sanitation codes, automobile safety regulations. Not a lot of evidence that it does. And my feeling is if we do this right, it will spur innovation, especially in our industry. We also, I think, need to start thinking about disconnecting systems. I mean, if we cannot secure complex systems, then we must not build a world where everything is connected and everything is computerized. Right? There are other models we can use, local collection, limits, systems that don't interact. And we need to start thinking about more distributed systems, more self-empowerment. And I don't think these large centralized systems are inevitable. I mean, there are technical elites pushing us in that direction, but the arguments aren't very good. And I believe that we will soon reach the high watermark of computerization and connectivity. And that afterwards, we're going to make conscious decisions about how and when to connect. And there might be a good analogy with nuclear power here. In the 70s was a high watermark of the use of nuclear power. That's when we started talking about nuclear power everywhere. We had a disaster at 3 Mile Island, and we didn't get rid of nuclear power. We just made more conscious decisions about when it was a good idea, when it was too hard and too dangerous. So I think that's coming. Not today. I think we're still in the honeymoon phase of connectivity. I think governments and corporations are still punch drunk on data. And just like you remember the NSA slogan, collect it all, we're in the middle of connect it all. But I think that's going to change. And morally, I think we need to change the fabric of the internet so that evil governments just don't magically have the tools to create a horrific totalitarian state. It feels like a bad idea. More generally, we need to start talking about our future. We rarely, if ever, have conversations about our technological future and what we'd like to have. Instead of designing our future, we let it come as it comes without forethought or architecting or planning. Right? When we try to design, we get surprised by emergent properties. I think this also has to change. I think we should start making moral and ethical and political decisions about how technology should work. Until now, we have largely given programmers a special right to design, to code the world as they saw fit. And giving them that right was fine as long as it didn't matter. I mean, fundamentally, it doesn't matter what Facebook's design is. But when it comes to things, it does matter. So that special right probably has to end. And also, for us right now, for all of us, we technologists need to get involved in policy. As internet security becomes everything security, internet security technology becomes more important to overall security policy. And we're never going to get the policy right if the policymakers continue to get the technology wrong. Think of the going dark debate. Think of the equities debate. Think about the voting machine debate. Think about driverless car debate. These are all important policy debates happening right now that desperately need technologists involved. And if you watched Apple versus FBI, what you saw were technologists and policymakers talking past each other. Right? The DMCA debate has that same problem. You watch the 702 debate later this year, you'll see the same thing. We need to fix this. We need to fix this. Technologists need to get involved in policy discussions. We need to be on congressional staffs, in federal agencies, at NGOs, part of the press. Because getting it right means having our expertise. And this is a lot bigger than security. I think we need to build a viable career path for public interest technologists, just like there is right now for public interest attorneys. If we don't do that, bad policy happens to us. All right, so quickly the main points. The computerization of everything will change our profession, right, even as it changes the world. And this is computers that affect the world in a direct and physical manner, being a fundamentally different animal in the eyes of the government. And like it or not, government involvement is coming. When computers start killing people, there are going to be consequences. And security is an exception to our bias for small government. I think this is coming faster than most people think. I've seen estimates in the tens of billions of IoT devices by 2020. We need to get ahead of this. We need to start thinking about this, the pros and cons. We can no longer answer none of the above to government regulation. And the worst outcome is that non-technological policymakers impose regulations on us. And lastly, we need to bring together policymakers and technologists. And that's hard to do, but we need to get involved in the debate. Thank you. So, microphone there and a microphone there. Please come up to the mic and ask your question. While he's coming up, I'll tell you we're doing a book signing and book giveaway at the IBM booth at 2:45 today. So if you all show up, it'll scare them, which would be awesome for my career. So please do that. And then at 4 o'clock, there's actually going to be alcohol on the show floor. This is a custom Bruce Schneier cocktail. It'll be handed out free, and we're not going to ask for ID, which is awesome. Don't tell them that. Yes?
Thank you for that. Do you have any thoughts about certification in terms of something has to be certified before it can get on X?
Yeah, don't know.
I'm thinking issues with rollout, decertification.
I can tell you why it's not going to work. Right? We might have it. So there are two types of certification. There's certification of individuals. Right? You had to be a licensed architect to design this building. You couldn't be just anybody. Right? So we could have that sort of certification, licensed software engineer, it's certainly possible. Or we could have certification for objects. I mean, think of a medical device. It has to be certified or a drug before it can be used. Both are possible. I think both have a role. Both are going to upend our industry dramatically, but that's in the government toolkit. And we're seeing it for medical device software. So my guess is you're not going to get a one-size-fits-all regulation, but you'll have different pieces, just like you for food safety, you don't have one regulation. They tend to be diced around. But those are possibilities.
Right. Because I'm thinking, the buyer isn't hurt by this thing, the seller isn't hurt by
Oh, yeah.
But the community is.
That's right. And that's the externality. And that's why there'll be something. But certification is certainly something you might see. You could probably easily see it in driverless cars. Right? Before driverless car software is on the road, it has to go through this testing certification environment, right? That's plausible. So here's there.
Thank you. So in the context of trying to find the middle ground between our fear of regulation and our love of small government, what are your thoughts around the influence that insurance can have in the information asymmetry of an uneducated buyer? How does insurance drive to become a better educated buyer of security solutions?
So insurance doesn't need a better educated buyer. Insurance just gives you sort of a buyer that can do the math. And insurance plays an important role in a lot of our security systems because they are educated in place of the consumer. Right? In order to to get insurance, you have to do these things. Right? In order for your network to be covered, you have to buy equipment from this list. Right? You can make up all things that insurance companies could do that raise the security of the ecosystem without the buyer's really knowledge. So I think insurance has a very powerful role to play. Again, a lot of reasons why you can't lift the existing models onto computers and networks. But I have been very bullish on insurance as being a mechanism that the market uses itself to raise security. But it's still, insurance works because there's a threat of liability, the threat of torts at the back end. So I need government to sort of force you to pay attention to insurance. That way insurance can work. Yes?
Bruce, I was wondering if you would be willing to serve as an example for us in your recommendation that technologists get involved in policy and consider running for president in 2020.
So I don't tweet, so that's kind of a disqualification right now. I'm not convinced that we are best served in front of the legislative podium. I think we're better served behind. I mean, I do get involved in politics a lot, but it is not as candidate and not as elected official. So, I mean, if you run for office, I think that's an awesome thing to do, and I'm not going to discourage anyone from doing that. But I am much rather advise elected officials, government agencies, and I do a lot of that. And I think that's something we can do in our existing jobs. You don't have to quit to be the person your Congress critter has on speed dial when something happens. Or you can take a spell at a government agency for a year or two and maybe get a sabbatical from work. I mean, that's happening more. So I think advisory role is just as valuable as being the person whose name is in the voting booth. Yes, please.
I've spent some time on that speed dial list, and I'm starting to work more on policy as well. And one thing I've experienced is some technologist pushback, as if by becoming involved in policy, I'm less of a technologist. I spend less time in front of the computer, and I'd like to know how we as technologists can reward instead of penalize those of us who spend more time in DC and less on GitHub. Well,
I'm trying to help by making people recognize it's important.
Okay.
And I think we need to look at public interest law as an example. I mean, you go back to the 1970s, there was no career path in public interest law. Now the ACLU has a job opening, I think, 200 applications for making 1/3 you'd make in a corporate job. And that took a decade or more to build that whole ecosystem where there are courses at universities, there are internships, there are paid jobs for you to go to this whole ecosystem. And we do not have that. There are some people who do this, but they're largely exceptions. We just need to make this the norm. I mean, I need someone at the Southern Poverty Law Center who understands algorithmic discrimination at a deep, fundamental level, because that's how discrimination works in the 21st century. I mean, we need those people in these organizations, right? At Amnesty International. I mean, it's going to have to know, because when you start seeing the kind of human rights violations in this century, they're going to be data-based. They're going to be algorithm-based. They're going to be surveillance-based. And I need people in those organizations who understand those. Just as I need them on congressional staffs and inside government. And in the press reporting on this. I mean, we all know one or two people who do this. Right? This is not nothing. Right? MIT offers a degree in this. It's technology policy, I think it's called. But there's still exceptions. This needs to be something that many of us do. I mean, right now, 10% of the Harvard Law School graduating class goes into public interest law. Right? Negligible percent of the computer science graduates go into public interest technology. That's what I want to change. Please.
I see that you focus on the role the government should have in regulations, but I would like to hear your thoughts about what should be our role, the security community and also the industry on that question.
Right, so industry, I don't expect to be anything but profit motivated. I mean, to the extent that the industry is with us, it's largely because it gives them good PR. I think this is even true for a company like Apple. I mean, they're doing what they're doing because we're rewarding them. So continue doing that, right? That's good. But for us as individuals, I think we have to support the right policies. I mean, I really think we need incentives being changed. And this is where we need to have our voice expressed not as consumers, but as citizens. And so I think that's what's missing. There's too much consumers, not enough citizens. All right, you're my last question.
I read your blog. It's awesome to see you live.
Thank you
for being here. And
I'll get you drunk later.
Yeah, sure.
Unless it's like awkward for you, in which case we won't.
No, I'm on.
Okay.
Yeah, I have this question. Like you were talking about that government will follow on this regulation of Internet of Things sooner or later. Even if they follow up and we have a regulation authority in by US government and the things get secure. But the billions of things you were talking about are all over the world, right?
Yeah.
So instead of talking about, because if the things in US get secure, but all over the world they are insecure, then also these things are insecure, right?
All right, let me stop because we got to end quickly. So he's right. It's a real important consideration. This is an international problem. A domestic-only regulatory agency. I mean, I kind of palmed a huge card there. But this is something we're used to. It's true in nuclear proliferation, small arms trafficking, money laundering, human trafficking, where we have domestic solutions for international problems. So we kind of know as a community how to slowly make things better, to marginalize states that don't go along. We do have the benefit that it's software, it's right once used everywhere. This will just be part of a solution. So yes, you're right, the international considerations are important. I don't think they make this unsolvable. All right, I have to get off stage. Thank you very much. I'll be out there, happy to answer questions. Come by the booth and I'll say hi again. There are flyers down there. The flyer gets you, I think, absolutely nothing except the booth number. Yes, it does. All right, thank you. Doesn't have a singular goal or focus. And most importantly, it's not something deliberately designed. This is an emergent property of the computers and networks that we've built. But for our purposes, it is smart things that act on the world in a direct and physical manner. Right? And of course, smart's relative. It's actually pretty dumb. But it's getting smarter. And it's getting more powerful through all the interconnections we're building. And this is what's eating the world. This is what means internet security becomes everything security. It means all of the lessons we know about our world become broadly applicable. Lessons of security and complexity, of vulnerabilities and patching, incident response, attackers, their tactics. Right? Everything we've done for decades is going to be everywhere, with two real important differences. One important difference. The effects are greater. Right? So decision-making algorithms are going to have lasting and serious effects. We think of predictive policing, algorithms that process loans or college applications or government services, algorithms that determine who gets smarts that figure out what all this data means and what to do about it. And so it's processing, it's memory, and a lot of it's in the cloud. And the third part are the actuators that affect our environment. And so the whole point of that smart thermostat is to regulate the temperature in the room. The whole point of sensors in our cars is eventually going to be to drive autonomously. So when you think about it, we're creating an internet that senses, thinks, and acts. And this is the classic definition of a robot. So I argue that we are together creating a world-sized robot, and we don't even realize it. Now, this isn't a robot in the classical sense. We tend to think of robots like we see them on television and in the movies. So discrete, autonomous entities in a metal shell with the smarts inside and the sensors and actuators on the surface. Data from Star Trek. But that's not what we're building. What we're building is distributed, It doesn't have a central brain. Different parts are controlled by different people. It doesn't release from jail or what kind of treatment you get at the hospital. Right, we're seeing these systems vertically integrated in a way that threatens the openness and accessibility of the internet. Right, more centralization, more monopolies. The proliferation of sensors that erodes privacy and allows ubiquitous surveillance on a global scale. Remember that Google Home you might win? You know, when all of these have the potential to deepen social inequities and reinforce social divides. And specific to our field, the immediate security threats are greater. Right? Cyber-physical systems have real-world effects. And the integrity and availability threats are much worse than the confidentiality threats. Right? So we're worried about information manipulation as an increasing threat. And both former DNI James Clapper and current NSA Director Mike Rogers have both testified about this. Denial of service is increasingly a threat as these systems become more essential. I mean, it's one thing for Reddit to be DDoSed. It's another for your home thermostat to be DDoSed in the winter. And is a computer that makes things hot. Your refrigerator is a computer that keeps things cold. Your smartphone is a small portable computer that makes phone calls. An ATM machine is a computer with money inside. Your car is not a computer, it's probably a 100+ computer distributed system with 4 wheels and an engine. And this is happening at all aspects of our lives. Right? I mean, a nuclear power plant is a computer that produces energy. And as everything becomes a computer, computer security becomes everything security. And this has 2 important ramifications for us. One, the knowledge that we all have about computer security will soon be more broadly applicable. It'll be applicable to everything. And 2, the restrictions and regulations that are in the physical world are coming into our computer world. And the beachhead of all of this is the Internet of Things. So when I think of the Internet of Things, I think of it in 3 pieces. There are the sensors that collect data about us and our environment. Right? So smartphone location data, or smart thermostats and light bulbs knowing who's in the room, or internet-enabled street and highway sensors. There's the
So today, the speaker is going to be Bruce Schneier. He's a CTO, IBM Resilient, and Special Advisor to IBM Security from IBM Resilience.
Okay, so that was a lot of announcements. We will have them straight. I'm pretty sure the IBM Home is not actually a home. Sorry, the Google Home is not an actual home provided by Google, but a device you put in the home you already own. So just to be clear on that. So thanks for coming. It's always nice to see everybody at RSA yet again. So in 2011, Marc Andreessen said that software is eating the world. It's an interesting quote, and I think what he's saying is that software is permeating every aspect of our lives. And the way I think of it is that everything is becoming a computer. And so your microwave oven